All right, so for the next part of this paper, we're going to be looking at some different lines and the points they pass through and using their slopes to tell whether they're parallel, perpendicular, or neither. And you'll see I already have some work done because I was already making this video and then the automatic lights in my classroom shut off. So I had to start over. So I'll talk you through these ones and then we'll go through and do some together down towards the bottom. So the first one says line C passes through 2, -2, and 5, 7. Line D passes through -3, 4, and 1, -8. Are the two lines parallel, perpendicular, or neither? And explain how you know. So what you need to do for each of these is go through and find the slope. So for line C, I use my 2 points, just find the slope. So 7 minus a -2 over 5 minus 2. And you should get 9 over 3, which is 3. For line D, again, we're just using these 2 points. So -8 minus 4 over 1 minus a -3 is -12 over 4, which gives me -3. And now we just need to check and see, are they parallel, perpendicular, or neither? They're very close to being parallel because I see 2 3s, but they would have to have the same sign. They're very close to being opposite reciprocals for perpendicular also, but one of these would need to be 1/3 for them to be opposite reciprocals. Remember, it has to be them flipped over and a different sign. So our answer here is going to be neither. We can't conclude anything. They're not parallel, they're not perpendicular. There's no special relationship. For example, 3, we're doing the same exact thing, just different points. So my line 1 passes through 0, 2, and 4, 0. So I take 0 minus 2 over 4 minus 0. I get -2 over 4, which is -1/2. For line 2, I take 4 minus 5, which is -1. -1 minus a -3 becomes 2. So if I compare these slopes now, -1/2 and -1/2, they are the exact same. When my slopes are the exact same, that tells me my lines are parallel. All right, next one, example 4, says suppose line M has a slope that comes out to equal 0 over 2 when using the slope formula. The other line, it should say line N, has a slope that comes out to equal 5 over 0. What is the relationship between these two lines? So if we try to simplify 0 over 2, that simplifies to 0. If I think about what that looks like, 0 is going to be a horizontal line. Now, if that's something you can memorize, that's great. Or just think about the slope. If I have a slope of 0 over 2, it's like my rise is 0 for every run of 2. So if I'm going up none, and I'm constantly just going over, that's going to give me a horizontal line. Now, 5 over 0 simplifies to undefined, because you cannot have a 0 in the denominator. An undefined line, we said, is going to be vertical. Again, if you want to think about it in terms of slope, if I'm going up 5 and going over 0 and constantly just going up, that's going to be vertical. So if I think about what these two lines look like, horizontal is this way, vertical is this way. This is a special case of perpendicular. We can't see that they're opposite reciprocals because 0 and undefined can't be opposite reciprocals, but those lines are perpendicular. All right, last one in this section says, example 5, line 1 has a slope of -5. Line 2 has a slope of 1 over 3. Which is steeper? Graph each line to help you find your answer. So what we'll do when we graph these is let's just start from some point. So if I have a slope of -5, that's like -5 over 1, right? My rise is -5 or down 5. My run is 1. So I'm just going to start at any point here. If I need to go down, I want to start up here and not down here because then I would run out of space. So I'm going to go down 5 over 1. Down 5 over 1. So that is a pretty steep line. Line 2 has a slope of 1/3. That's like going up 1 and over 3. So I'm going to just start down here. I'm going to go up 1 over 3 up 1 over 3, up 1 over 3, and I get a line here. Now, if you're not sure where to start your lines, it really doesn't matter. You just are trying to visualize what these slopes look like. So they can be anywhere on that plane. So hopefully you can notice that this one is going to be steeper. Just because a number is negative doesn't mean it can't be steep. So the rule is whatever slope has a bigger number. So here we were comparing 1/3 and 5. Regardless of the sign, whatever slope has a bigger value without the sign, that's the one that's going to be steeper. So let's say, for another example, I had -9 and 9 as my slopes. If this value is the exact same, they're going to have the same amount of steepness. If I had something like 5 and -7 as my slopes, they're both pretty steep, but look at the value. I have a 5 and I have a 7. So this is the one that's going to be steeper. One last example. Let's say I have 3/4 and I have 2/3. If you can't compare fractions, that's okay. Put them in your calculator and turn them into decimals, see which is greater. Or you can just graph them on a graph or on a piece of paper or on your whiteboard and just test it out. And 3/4 has a greater value, so it's going to be a steeper line. So you can always depend on that rule. So now I want you to stop and practice, go back to the worksheet and do numbers 6 through 9, which deal with these same concepts in part 2. I'm going to end this video and start another one and hope the lights don't go out this time. So go ahead and do those problems and then check back to the next video when you're finished.